We wake up each morning inside a reality that feels stable, solid, and unquestionable. The floor holds us. The clock ticks forward. Objects stay where we left them, because leads to effect in a neat and predictable line. Without realizing it, we assume something even deeper, that reality is built in a way that makes sense to us. That assumption is so natural, we rarely notice it. From childhood, our brains construct a model of the world that prioritizes survival. Distances appear consistent. Time flows uniformly. Solid objects don't pass through one another. This model works remarkably well for navigating daily life. It keeps us alive. It allows us to plan, to build, to communicate. But here is the unsettling question. What if this model is not reality itself, but merely a useful approximation? Richard Feynman repeatedly pointed out something deeply uncomfortable. The universe does not adjust its structure to preserve our intuitions. It does not simplify itself so our brains can feel at ease. Instead, it behaves according to principles that often defy the very categories we rely on to interpret experience. The shock is not that physics is complicated. The shock is that reality itself may not be structured in a way that matches the way we think. Consider how instinctively we assume that space and time are absolute, that there is one shared now, that events unfold in a universal sequence. These assumptions feel obvious because they are built into perception. But physics has shown that what feels obvious can be profoundly misleading. The deeper scientists looked, the more they discovered that the universe operates independently of human expectation. Particles behave like waves. Time stretches, simultaneity dissolves. Objects are not solid in the way they appear. Even the vacuum is not empty. Yet our senses present a seamless, coherent stage on which reality performs. This is where the tension begins. If reality were designed with us in mind, it would align with our cognitive architecture. It would preserve intuitive categories. It would respect the boundaries our brains naturally impose. But instead, the further we probe, the more those boundaries collapse. Feynman noticed something subtle but profound. The universe does not care how we imagine it should behave. It does not care that uncertainty feels uncomfortable. It does not care that non-locality sounds absurd. It does not care that relativity contradicts everyday experience. It simply behaves, and we are left to adjust. This realization carries an emotional weight. It suggests that what we call reality might not be a fundamental layer of existence, but a filtered version shaped by biology. Our nervous systems evolved to detect predators, find food, and reproduce, not to perceive quantum fields or space-time curvature. In other words, our experience of reality may be optimized for usefulness, not truth. That idea destabilizes something deep. If the universe is indifferent to our categories, then common sense becomes a local convenience rather than a universal guide. What feels self-evident may only be a feature of our perspective, and that is where the unsettling thought takes root. Perhaps the universe does not care about reality as we define it. Perhaps reality, in the way we experience it, is not the universe's concern at all. If the universe were aligned with human intuition, physics would feel like an extension of everyday experience. Instead, it feels like a rebellion against it. Take motion. In daily life, we assume that if two events happen at the same time, they are simultaneous for everyone. That seems obvious. But Einstein's relativity shattered that comfort. Two observers moving relative to each other can disagree about whether events occurred at the same moment. And both can be correct. Simultaneity, something that feels universal, turns out to depend on perspective, or consider time itself. We treat it as a steady river flowing at the same rate for all. Yet relativity shows that time stretches and compresses depending on speed and gravity. A clock on a fast-moving spacecraft ticks differently from a clock on Earth. Time is not a universal backdrop, it is flexible. Common sense protests. Time is time. A second is a second, but the universe disagrees. Then quantum mechanics arrives and pushes intuition even further. Particles do not behave like tiny billiard balls. They behave like probability waves. They do not occupy definite positions until measured. They can exist in superpositions, multiple potential states at once. Worse still, entangled particles remain correlated across vast distances in ways that defy classical explanation. Measure one, and the other responds instantly regardless of separation. It does not transmit information in the traditional sense, but the correlation itself challenges our idea of locality, or instinct search for hidden mechanisms. There must be something underneath restoring order. But decades of experiments confirm the same uncomfortable truth. Nature does not revert to classical clarity when we demand it. The equations predict results that contradict intuition, and experiments agree with the equations. This is the pattern Feynman emphasized. Whenever physics forces a choice between common sense and mathematical consistency verified by experiment, common sense loses. And that is deeply unsettling, because common sense feels like reality itself. It feels foundational. Yet again and again, physics reveals that what feels solid is emergent. What feels obvious is approximate. What feels fundamental is often derivative. Even solidity, the sense that matter is firm and continuous, dissolves under scrutiny. Atoms are mostly empty space. The rigidity we experience arises from electromagnetic interactions between charged particles. The solid desk beneath your hand is a field interaction, not a compact block of substance. The universe does not modify its structure to preserve our perceptual categories. It allows space to curve, time to dilate, particles to blur, and causality to operate in ways that stretch our conceptual framework. Feynman famously warned students not to say they understand quantum mechanics in the everyday sense. The behavior of nature at its core does not resemble the mental pictures we evolved to use. It can be described precisely. It can be predicted with extraordinary accuracy. But it cannot be reduced to intuitive imagery. This reveals something radical. Reality, as described by physics, is mathematical before it is visual. It is relational before it is tangible. It is probabilistic before it is concrete. Our brains prefer narratives and objects. The universe prefers equations and symmetries. That gap is not a temporary misunderstanding waiting to be corrected. It may be structural. The deeper physics goes, the less it resembles the world of ordinary experience. And the more we discover, the clearer it becomes that the universe is under no obligation to align with our sense of what is real. It behaves as it behaves, and we must decide whether we are willing to follow the evidence, even when it leads away from the reality we thought we knew. Richard Feynman did not try to soften this blow. He didn't wrap physics in comforting metaphors or pretend that reality secretly aligns with human intuition. Instead, he said something far more unsettling: nature is the way it is, and it does not care whether we find it reasonable. That sentence alone contains a quiet revolution. Most people approach science with an expectation hidden beneath curiosity. They assume that if something is explained clearly enough, it will eventually make sense. That behind every strange result there is a deeper, more familiar mechanism waiting to restore order. Feynman rejected that hope. He warned students not to fool themselves into believing they understood quantum mechanics just because they could repeat the equations. The mathematics works. The predictions are precise. But the underlying behavior, particles interfering with themselves, probabilities replacing certainties, refuses to conform to everyday logic. And Feynman did not treat this as a temporary gap in knowledge. He treated it as a feature of reality. This is where his honesty becomes almost brutal. He admitted openly that human intuition evolved for survival on the savannah, not for interpreting subatomic phenomena. Our brains are tuned to track medium-sized objects moving at slow speeds in weak gravitational fields. Of course, quantum mechanics feels absurd. It was never meant to feel natural. The discomfort we experience is not evidence that physics is incomplete. It is evidence that we are limited. That idea flips the usual narrative. Instead of assuming that reality must eventually resemble common sense, Feynman assumed that common sense must evolve or break. Under pressure from evidence, he placed trust not in intuition but in experiment. If nature behaves in a way that contradicts your expectations, he would say, then your expectations are wrong. There is something almost cold about that stance. It removes the universe from the center of our psychological comfort. It denies us the reassurance that the cosmos is structured to be comprehensible in human terms. But there is also something deeply liberating in it, because once you accept that the universe does not care about your sense of reality, you stop demanding that it justify itself. You stop forcing explanations into familiar shapes. You allow it to be strange. Feynman's approach was not nihilistic. He was filled with wonder. but his wonder was rooted in acceptance, not denial. The strangeness of quantum behavior did not frustrate him because it violated common sense. It fascinated him because it revealed how much larger reality is than our mental models. This perspective requires intellectual humility. It requires admitting that understanding does not mean converting the universe into a story that feels intuitive. It means learning the language nature speaks, even if that language resists metaphor. And perhaps this is the most unsettling part of all. If the universe does not care about our version of reality, then reality as we experience it may not be fundamental. It may be an interface, a simplified dashboard that hides deeper complexity. Just as a computer screen shows icons instead of circuitry, our perception may show objects instead of quantum fields. Feynman never claimed that the universe was obligated to match the dashboard. He accepted that it runs on deeper code. That acceptance is what sets him apart. It is not that he solved every mystery. It is that he refused to invent comfort where none existed. He noticed the indifference of nature, and instead of resisting it, he leaned into it. The universe does not adapt to our understanding. We adapt to it, or we are left behind. At this point, something subtle but crucial comes into focus. Physics describes, it does not justify. That distinction is easy to overlook because we often blur explanation with meaning. When someone asks why something happens, they are usually not asking for equations. They are asking for purpose. They want to know what it means. But the universe does not appear to operate in terms of meaning. When physicists write down Maxwell's equations, Schrödinger's equation, or Einstein's field equations, they are not uncovering reasons in the philosophical sense. They are uncovering patterns, reliable, repeatable relationships between measurable quantities. These patterns allow prediction with extraordinary accuracy. Yet nowhere inside those equations is there a statement about intention, gravity curves, space-time, particles follow probability amplitudes. Energy is conserved. These are descriptions of behavior. They tell us what happens and how reliably it happens. They do not tell us why existence itself has that structure instead of another. Feynman was careful about this boundary. When pressed with ultimate why questions, why these laws, why this universe, why existence at all, he resisted the temptation to stretch physics into metaphysics, not because he lacked imagination, but because he understood the limits of the method. Science builds models that match observation. If the model predicts outcomes correctly, it survives. If not, it is replaced. This process is powerful, but it is silent about meaning. It does not answer whether the universe has purpose. It does not address whether reality is fundamentally for anything. We instinctively assume that deeper understanding should eventually lead to deeper significance, that if we dig far enough, we will uncover a narrative core. But the deeper physics goes, the more it reveals structure without story. Quantum fields fluctuate. Symmetries break. Constants take specific values. These features can be measured, calculated, refined, but when we ask why the constants have those values rather than others, physics can only answer, because that is what we observe. There is no built-in reassurance, and this is where the phrase, "the universe doesn't care about reality," becomes sharper. The universe does not appear to preserve human categories like meaning, intention, or narrative coherence. It maintains consistency. It maintains symmetry. It maintains lawful behavior. But it does not adjust those laws to satisfy existential curiosity. Reality, as we experience it, is layered with interpretation. We assign significance. We construct stories. We create purposes. These are deeply human activities. They are powerful and necessary for culture, morality, and identity, but they are not embedded in the equations of motion. Feynman recognized this separation. He admired the beauty of physical law without pretending it carried hidden messages. The elegance of mathematics was enough. The precision of prediction was enough. The fact that the universe could be described at all was astonishing, even if it offered no commentary on why it exists. This perspective can feel cold, even alienating. Yet it also clarifies something important. If meaning is not imposed by the structure of physics, then it is not constrained by it either. The absence of cosmic intention does not eliminate human significance. It simply relocates it. The universe may not care about our concept of reality, but it does allow us to explore it, question it, and describe it with increasing depth. And perhaps that permission, not purpose, not reassurance, but permission, is the most honest foundation we are given. At first, the idea feels bleak. If the universe does not care about our intuition, our expectations, or even our sense of meaning, then what are we left with? No grand narrative, no built-in purpose, no cosmic reassurance that reality aligns with human categories, but look closer. And something unexpected emerges. Indifference is not hostility. The universe does not resist us. It does not punish us for misunderstanding it. It does not conceal itself out of malice. It simply operates quietly, consistently, lawfully. And within that consistency lies an extraordinary gift, reliability. Because the universe follows patterns, we can discover them. Because it does not bend to human preference, its laws remain stable across time and space. The same equations that describe distant galaxies apply here on Earth. The same quantum behavior observed in laboratories governs the interior of stars. Indifference creates uniformity. Uniformity makes science possible. Feynman understood this deeply. He did not need the universe to care about his comfort. He needed it to be consistent. And it is. The electron does not change its charge to make our metaphors easier. Gravity does not soften its curvature to preserve common sense. Nature's indifference is precisely what allows trust in experiment. There is a strange beauty in that. If reality were shaped by human expectation, it would shift with culture and belief. It would fracture under disagreement, but instead it stands apart, objective, testable. Independent of opinion, that independence is not coldness, it is stability. And from stability comes freedom. Freedom to question assumptions. Freedom to discard illusions. Freedom to replace comforting stories with more accurate descriptions. When the universe refuses to validate our intuitions, it invites us to grow beyond them. This is the deeper conclusion Feynman seemed to notice. The shock of quantum mechanics, the distortion of space-time, the collapse of intuitive reality. None of these are insults to humanity. They are expansions of perspective. They show us that existence is larger than our evolutionary toolkit. Yes, reality as we experience it may be a filtered interface. Yes, meaning may not be written into the equations. Yes, common sense may fail at the deepest scales. But none of that diminishes wonder. If anything, it intensifies it. The fact that a primate brain evolved for survival on a small planet can uncover the mathematical structure of distant galaxies is astonishing. The fact that we can detect particles that flicker into existence for fractions of a second is astonishing. The fact that we can realize our own perceptual limitations is astonishing. The universe does not care about our definition of reality, yet somehow, within its indifference, it permits awareness. That may be the most remarkable fact of all. Not that reality aligns with us, it doesn't, but that we can align ourselves slowly and imperfectly with reality. And in that alignment, even without cosmic reassurance, there is something that feels profoundly meaningful.